Let's start with the session. Uh, Good evening, guys. So let me start with some introduction to Colab. Colab. I think you people were more new to this Colab because Colab is also it's an interface where you can work with the Python. It was developed by Google. So there is some drawback using your Jupyter notebook. So in your Jupyter notebook, the main problem is will come when you work with the deep learning models. So this deep learning, actually, this artificial neural networks for computations, they will take a lot of time. So if you are trying to compute your neural networks with your CPU, it might take 2 days, 3 days, even it can take 5 months, or it can take a 1 year to train your models using your CPU. So this whatever the neural networks that was designed by Google, like TensorFlow, that was given by TensorFlow, or PyTorch by Facebook. Okay, so all these basically this TensorFlow neural networks are computed using GPUs. So in your PC you have CPU and GPU. So CPU is mainly for your computer processing. GPUs are for your graphical processing. Like when it comes to gaming side, to compute that graphics, like to change from one image to an image, like to give something more, to give some better graphical experiences. So they will come up with you some like graphic cards. So Google has developed TensorFlow under the CUDA computing. CUDA is also it's a one of computing is it is also one of a programming language. So CUDA is basically done in NVIDIA graphic card. Okay, yeah, I think you people knew about this NVIDIA graphic card. NVIDIA, I think G4, RTX, GTX. We have Triton, we have Tesla. Okay, different of graphic cards. We like it is available in our market. So the TensorFlow, the Google, they has developed this. They have embedded these neural networks using the GPUs. So this NVIDIA GPUs. Okay, so by default your GPU, like by default your Jupyter notebook are not able to perform. They are not able to compute using your GPU because they only compute your programs or your language coding only with CPU only. They are by default they are not like linked with GPUs. Okay, is there is a possible, of course you can use your Jupyter for computing neural networks also, but if it is possible only when your PC, when your local PC has something inbuilt NVIDIA graphic card. Okay, only NVIDIA. So your models cannot like only TensorFlow only work under NVIDIA graphic card only, not under Radeon, I think, or Intel graphic cards. Okay, so the TensorFlow works under only NVIDIA graphic card. So if your PC is having this NVIDIA graphic card, I will be sharing your link when we will at the time of starting our deep learning module. I will share you one YouTube link so you can follow through the steps and you can install TensorFlow GPU in your Jupyter notebook only. So if NVIDIA graphic card is not available in your PC, there is not a big deal. So we have Colab. So Colab is basically they have built upon GPUs only. Okay, they have TPUs, tensor processing unit. They have GPU, graphical processing unit. Okay, so I will show you something demo upon these GPUs. Colab. If you search in Google Colab, you will get the Colab. So the first one, welcome to Colab Collaboratory, Colab Google Research. So okay, after entering, just you will get something like this. Cancel. So this is something introduction to Colab. You will get something stuff like how to get started with Colab. What are the things you can be available from Colab. So let me open some file. File, new notebook. Let me open new notebook. Okay. So this is the new notebook I'm opening. Yeah, this is the new notebook. Let me title it something like TensorFlow. Let me title it ML demo. Okay. So this is the cell you can run. You can import NumPy as MP, or import pandas as PD, import matplotlib.
Sir, your notebook is not visible to us, sir. Just it is showing what is collaborative. That phrase
Okay,
only.
okay, fine. Yeah, fine, fine. Okay, okay. So is it now visible?
Yes, sir. Now it is come.
Actually, the tab has sent to the new page. That's the reason. So this is the collab. Okay, so this is the collab. So this is the cell. So just I'm typing import numpy as np, import pandas as speed, import matplotlib, that pyplot as plt. Then you can run it. See the play button symbol, it will run the cell. So the cell has been executed successfully. So where is the GPU? How you have to select the GPU computing? Okay, for this purpose, you can go for this runtime. Okay, in the runtime, change runtime type. Okay, here you can go for this arrow bar, like here we are having none GPU TPU. Select the GPU and click on save. Okay, now your collab is backend. The backend of your collab has been successfully embedded with GPU. Okay, like I will show you my another file that where I have computed TensorFlow models. See, this is the one. Actually, by default, actually this I have done the previous only. So I will show you some. Okay. So first thing is that, see, I'm dealing with something called TensorFlow modules. So these TensorFlow modules, they compute very faster when our GPUs when the GPUs are only available. Okay, they can run in CPUs, but the time ticking process will be more compared to GPU. It can take even half day, 1 day, 2 days, 3 days, 1 month, depend upon your data and depend upon your model. When you go for CPUs, but when you go with GPUs, the computations will be more faster than the CPUs. Okay, sometimes your GPU processing also may take 2 days, 3 days. Okay, I think it's not with the problem is not with us, because when you go for something like some million size of data sets, it might take that time. Okay, when your model is too complex, okay, when your model is too huge, so the time complexity can be a lot. So the first thing I'm doing is it's a run, changing my run type, and the GPU is, of course, my default is GPU save. Then I'm running this cell. You have too many remnant existing continuous. Think that this process. Okay, so runtime, change my runtime so it's the same. I go for too many active sessions terminate the user. So this cell has been run successfully. Then something like exploring. This is the image classification. Something basic call we basic. So from here cell I'm just downloading the dataset. Actually, it is in the dataset in an API format. So using this, because all of these modules are in API format. So this dataset is like the fashion eminist dataset is, it is like by default it is with TensorFlow using by default it is in Keras module. So using Keras, I am downloading this dataset. Okay, this cell has been done. Then I'm giving something like exploring the datasets. This techniques called it as something class names and training dot shape something. Training dot shapes. Then you got labels, text labels, and shape and labels. Then processing the data, like I'm showing, displaying the image. So it is looking something like a angle shoes, I think, angle boot. And I'm normalizing the data. Normalizing data means converting from color image to black and white. Just normalize means very simple. You will divide each and every pixel by the largest value of pixels. The largest value of pixel can be 255. Minimum can be 0. So now each and every my images is converted into a black and white. Now I'm just building a model. So this is the actual model building. This is a small basic model. This is like a very small. This is like something like Hello World. Okay, Hello World program. So by Keras, and I'm taking some models, denser models. Okay, I'm having 10 class labels. So my final output will be 10 neurons. Then I can check my model dot summary, like how many layers there is. One flattened layer means your images will be flattened because your images are in 28 cross 28 pixels. By default, our artificial neural networks, they doesn't work under two-dimensional data. It will only accept data in one-dimensional. So to convert this two-dimensional data into one-dimensional data, we must flatten them. Means 28 cross 28 is called 784. Now, so after flattening, this 28 cross 28 will become a single array. Okay. So we will discuss more about it in our coming sessions after in our deep module session, deep learning module. And I can take something like a graph visualization also. Now compiling my model, like taking the optimizer and loss functions, matrices. Now I'm training the function. Now I'm training. This is where the time, see, if your everything goes well with your CPUs, but coming to only this fit function, it might take more time in your CPUs, your CPU Jupyter, like Jupyter's running on CPU, it will take more time to compute. But Colab having GPU, that's the reason it is computing much faster. Okay, that's the reason. So that's the benefit of using Colab. Okay, my model is performing well on training data set because I'm getting something like 91%, 92% accuracy on my training data. Okay, still it is going on. How many epochs did I capture? Oh god, 50 epochs. Let me terminate it. Just start then to interrupt execution. Then evaluating accuracy, then testing my models. Okay, so everything. So this is how you can use Colab. So the next thing is that how to go with the data sets, because your data sets in your local systems, like in your local PC, but how to import them to your Colab. Okay, for the purpose, first thing you have to do is that you have to go for your Google Drive. Okay, my drive, Google Drive. So this is my drive. This is my Google Drive. Okay. So in my Google Drive, I'm having actually by default I'm having something like data sets, or CSV files, something like compressed images or thesis, something. Okay, something I'm having my folders. Okay, see now actually first thing is that first thing if you want to work with any data set, first thing you have to do is you have to import the data set to your Google Drive. So the importing can be done using this. If you go for new, Then we will have your file upload, folder upload. File upload means you can only upload a single file at one time, but folder upload, you can upload like n number of files at a single time. Okay, so let me go for a single file upload. Then it will go to my local PC. So I will select the way to be gone of here. I'm in crime dataset. See in my downloads. See again in my crime dataset, I am having this crime.csv file. Okay, then open. Okay, trying to open. So yes, something bar. You will get something bar. It is uploading. So uploading taking some process because it's a 60 MB CSV file. Okay, so then a CSV file has been uploaded to your my drive. Okay, let me go here. You can see here you will have crime.csv. Crime.csv. Just let go for. So after the file is uploaded in your drive, then let us go for this our collab. Okay, after collab. See now how I am importing that. Let's see. Look at how I am importing that data set. Just a minute. From Google.collab, Google.collab import drive. Okay. Then drive dot mount brackets underscore content content and slash drive around this cell. Okay, after running the cell, see you will get a link. Okay, see you will get a link. Go to this URL in a browser. So let me click. I'm clicking on this link. So you can see. So it will directly it will direct it to your Google, like something Google page. It will ask you to select any your account for login. So I will select my account. Okay, then sign in. I will say for sign in. So you will have something like a code. Okay, something code. You can select it for copy. Okay, this code is copied, and again I will go for this my collab file. Okay, in this collab file, you can see here enter your authorization code. So in this you can enter the code Control V, then you can press enter. Okay. See, now your collab is mounted with your Google Drive. Okay, now let us read the CSV file. Before reading CSV file, firstly, let us take the because for reading a CSV file, we must need the path of it. Okay, so we must need the path of it. So let us go for the path. Let us go for the path. So to know the path of your CSV file, firstly go for this file. You can see something like a file bar. Okay, click on this file icon. So you will get something like drive sample data something. Okay, so I will go for my drive. Okay, because my CSV files are in my drive. Again in my drive, my folder is because the CSV file I have uploaded that is in my drive. Okay, So in my drive, we can have a number of samples. Okay, let us go for and find out this crime CSV. Any CSV file. Let me go for. Yeah, here we are at crime.csv. Okay, crime.csv. So in this crime.csv, you can see here three dots. Okay, three dots. Click on it. You can see here copy path. Okay, with this copy the path. Now you can see it. So df is equal to ed dot read pd dot csv brackets open, then inverted commas, copy that path. So now content drive my drive crime.csv. Okay, after running this cell, it is not different. Okay, so then let pandas. Sorry, I haven't imported pandas. Let me import pandas. So import pandas as pd. Okay, so now your Google, now your CSV file has been read to this df variable. Okay, so you can perform. You can now. So you have now access to your CSV file. So the next thing is up to you. You can perform anything, like something like data exploration or data pre-processing. Okay, so if I'm typing df.it, I'm getting the. Okay, so this is how you can work with Colab. Okay, is it clear? Colab.
Yes, sir.
Fine.
Yes, sir.
Yeah, okay. Actually, it has taken half an hour. So let us start with something like more machine learning. So okay. So yesterday, I think we discussed something about machine learning. So what is machine learning? Why we are calling it as a machine learning? And I have shown you some of the applications in machine learnings in recent years, and I have shown you some of the persons who are contributing to this machine learning and the companies what are they looking for. Do you know one thing? Um, machine learning is the highest paid job. In the tech era, in the technology era, machine learning engineerings are getting a high package. In USA, it is about per annum you can get 1,65,000 or something like 2,50,000, $2,50,000 per year. So I think it is about something 80 lakhs. I think it's about 80 lakhs, 90 lakhs. It might be. Yeah, 80 lakhs or 90 lakhs. This is the basic pay of. This is the average pay. This is the average pay. So that depend upon your talent. Either you are expert. If you're an expert in machine learning, you can get above from, like you can go for something like 3 lakhs, 5 lakhs dollars per annum. Okay, if you are a beginner, you can get something below of it. Okay, something 50 lakhs, 40 lakhs per dollar. It is in USA. Coming to India, India is also looking for most of the machine learning engineers, like companies like Flipkart, Mintra, Ola, and KPMG, and Deloitte. Deloitte is also an United company. So most of the companies, even Google in India, Google India, or Microsoft India, Facebook India, they all are looking for machine learning and deep learning engineers. Okay, and they are ready to pay high based upon your talent. If you are good at in machine learning, they are ready to pay. Okay, so in machine learning, we have different type of learning methods. Okay, so we have the main three methods are supervised learning, unsupervised learning. The third is the reinforcement learning. Okay, so the third one, the reinforcement learning, is mainly used in gamings. Okay, in gaming, like either it may be in PUBG, Free Fire. I think it's a Free Fire, Pokemon Go, or something like Clash of Clans, COC. Okay, so in these games, most of the developers, they are using reinforcement learning. Reinforcement learning is nothing but, see, in gaming you can see that in a gaming there is also learning process. Okay, so if you're let us take, if you're playing any of, like something, I have not much about this PUBG and Free Fire. So when you are going with this PUBG or a Free Fire, there is something that you are killing those people. Like someone is pointing upon you, someone is trying to point upon you. Okay, like you have to hide somewhere. You have to hide somewhere because so the hitter should not know about your place. Okay, so first time if you're new to a PUBG, if you're new to the PUBG, so at the starting stage you will be detected. You will be detected by the other persons because you are new to the game. Okay, and the game is also new to. Okay, then after throughout you're playing, after you're playing and playing, so your game will be improved. Your game will be improved that you are not able to identify by the other persons. Okay, so how this process is done? Basically, this process is done using reinforcement learning. So it is something like reinforcement learning is that giving some reward and penalty. If you're going in a good direction, so you will be awarded with rewards. If you're going in a bad direction, like in a wrong direction, so you will be awarded with some penalty. They will give some penalty upon you are going in the wrong directions. Try to recorrect it. Okay, this is the reinforcement learning. Okay, so I think it's a note type. I'm not covering this reinforcement learning in this module because it is something. It's a different part. Okay, for reinforcement learning. Okay, if you're wants to go for any gaming companies, so I would prefer go for reinforcement learning. Not a problem. I will give some overview about reinforcement learning, but I won't go for the coding because the coding part is a lot. Teaching them and coding part, it will take for me a 5 days to cover this reinforcement learning. So that's the reason I will give the overview of the reinforcement learning. Okay, so now let us go for the supervised learning and unsupervised learning. Okay, so supervised learning is nothing but uh, see, I am giving you some like see, you are having a data set. You are having a data set, or you are having any like something data called. Let us take stock market data set. Okay, in the stock market data set, see, you are having certain feature columns. Feature columns are nothing but they are the training data. Feature columns are, we call it as the training data. In the training data, we have different type of feature columns. Feature columns like profit of the certain company for the past 30 days, and the loss of that company past 30 days, the products they are releasing, the tweets they are making, because nowadays tweet also matters a lot. Tweets, because recently you can see the Adani group has reason it has lost around, I think, $2 billion. I think it's not 2 billion. I think the figure was about high. After some of the fellow company member has tweeted something about the company, suddenly the stock of the company has went down. There is a lot of loss to the Adani company. Similarly, you can go for this Elon Musk. Elon Musk, actually, there was a more controversy issue about this Bitcoin. So to counter this Bitcoin, Elon Musk introduced it called Doggy Coin. So he has made a tweet that, so if your people are having a doggy can, so by purchasing it, you can purchase a Tesla Model X or Tesla Model Y using this doggy can. So after tweeting this message, suddenly this most of the people are like they moved to doggy can, like they were selling their bitcoins and they were going for this doggy can. Okay, so this type of, because there are certain factors that are affecting this data set. When it comes to stock market has everything. If you're trying to invest anything in a stock market, you should follow the news. What are the news today? Okay, whether, because you can see this in corona pandemic. In this corona pandemic, there is no there is, everyone is from work from home. Most of the people are doing work from home, study from home. Okay, in this process, the stock market is not performing well. Sometimes it is going in profit, sometimes it is going in loss. Okay, so for a stock market, we have the feature columns are nothing but the training data is, let us consider training data. The first training data will be my profit of that company for the past 30 days. How much profit is making uh, in the past 30 days, that company. How much loss that is generated by this company. The third can be any tweets by the CEO, CFO, chief executive officer, chief financial officer, or something like digital media partner by the company. Because this most of these social network platforms were handled by the digital digital partner only. Digital, I think the way I don't know the name. Something the persons related to something digital media. So they will handle these twitters. If you go for something like any franchise team, let us go for RCB. So RCB in a Twitter account or in Instagram account, it was not handled by the team head, like it was not handled by the RCB head. It is handled by something like digital media. So there is certain persons who capture that videos or he will tweet about it. Okay. Similarly, for a company, we will have something digital media. Okay. So by considering all these features, so my data, what will be my the output label? My output will label can be what will be the profit of this company in the next day. For tomorrow, what my machine learning model, like my aim or my motive is to that my objective is that considering these future columns I should predict the stock or the profit. What is the stock price, what is the stock price can be, or what is the profit can be, what is the loss, whether the company is going in profit or in loss. So my aim is to predict that one or to predict that one. Okay. So this is one prediction. Okay. The second one can be uh, so we are having something like a yeah, bank. In finance, let us consider go for finance. In finance, we in finance in banking sectors, so you people will like applying for a loan. Okay, you will people something like if you want any loan, home loan, car loan, study loan. So okay, you approach a bank and you there is something procedure. Okay, you must follow that procedure. You should fill the form. After filling the form you will submit it to the like the from the regional branch manager. Okay, so it will the scrutiny. There is something process called scrutiny. They will scrutiny your. In the olden days, there is a process of scrutiny. Like the manager will check your application form. Okay, okay. So and so person about your document, land documents, something like your home documents. Okay, whether this person is able to afford this loan, like either he is able to repay this loan. He will check each and everything. Okay, we call this is a manual thing. Okay, it needs something like a manpower. Okay, so but my motive is that but my objective is that why what is the need of this manual, let us automate this. Okay, why there is a manager, or why we have to keep some staff in our in our bank. Why should we pay them to like whether to say something that whether to classify this loan as a good loan, the person is a good one or a bad one. Okay, so for this purpose we can introduce something like a machines. Okay, automation systems. Automation system is that so the whatever the application form was submitted by the user, so it will send to my machine. So in my machine I will deploy some machine learning models. So that machine learning models, it's by considering the application and considering the documents, some land documents or something like land documents or something we call the beneficiary signatures, and again credit score. So considering all this, my machine learning model will say, okay, this person is able to pay he can afford the pay, he can afford like he can repay the loan. So he's a good person. So okay, we can sanction loan to him. Okay, or else if the person is not able or not capable of paying loan, then my model should answer me. My model should say me that he's not able to pay the reloan, so cancel or reject this loan. So it have to say that. So okay, this is a supervised learning. The supervised learning, you are having a label. You are seeing in your supervised learning, we are having some different type of. So okay, so in my supervised learning, we basically have see training data. So it's not a training data. We call this as future columns data or future data. Okay. See, we call these as future columns or futures data. And simultaneously, I am having the label. Simultaneously, I am having the labels. Okay. Labels. What are the labels? See, in case of my stock market, my future columns or my futures data will be the profit that a company has made since for the past 30 days, or the tweets that was made by the business persons, or like something like the any deflations in our GDP, any announcement of our finance budget, because your stock market predictions depend upon your the budget announcement also. So okay, considering all this, so all this can be my future data. What will be the label? My label can be to predict the stock value, to predict the stock value of this company, stock value of a certain company for next day. What will be the stock value of this company for tomorrow? Okay, so this could be my the label. Okay, this is for stock market. Let us go for the banking example. In my banking example, my future data can be application form. Second one are your documents. Documents can be your land documents, how much you are having, how much properties you are having. Okay, like gold or something, land property, because they give most of the companies, banking companies, they give you the loan considering your documents only. The application form, documents, then something we call credit score. Okay, nowadays it is something, credit score is a good one. Credit score, then what when we go for application form, documents, credit score again. Okay, this let us consider. Okay, this three will be my future columns. What will be my label? So my label can be yes or no. Yes, yes. For yes, I will take one. No. For no, zero. Means my label is that considering this application, considering this application form, documents, credit score, my model, my machine learning, like whether there should be a considering these documents, so that I have to classify, I have to detect whether this person is capable of loan, they are capable of repaying the loan, or they are not capable of repaying the loan. So if the person is capable of paying the loan, then I will keep yes one. If he or she is not capable of paying the loan, or he or if he is like they are ready to keep any IP, then it will say no. Okay, so this could be the approach. So okay, can anyone say in this talk, are you people were familiar about this continuous values and discrete values?
Yes, sir.
Okay, can you say what are these continuous values and discrete values?
In continuous values, we can predict the output at any instant of time, but in discrete values, we can predict only at certain points.
Okay, much closer. Fine. That's a good one. So okay, I will give you like a, so my continuous value can be continuous. It's very simple, something like say 19.0, or something like 22.23, 10, 40.2, gamma t. Okay, so this could be my the continuous values. So continuous values are basically, they can be in decimal format. Okay, continuous. So they can be in the decimal format. Okay, so let us take, stock market. Stock market label can be something. It can be 19. Okay, something it can be 22.3. Means, so for the incoming, for tomorrow, the stock market of the stock value of this company can be 22.3 rupees. Okay, we call it as something called IPO. IPO, I think I call it in stock terminology. We call it as IPO, basic price. I think I'm much not familiar about it. So 23.3, or it can be 10 rupees, or it can be 40.2 rupees, 50 rupees. Okay, these are the continuous values. You can have something. Example of again continuous values can be weight. Let us go for the weights and heights. If you go for the weights, your weights are measured in basically. Your weights are measured in basically. You can see, we will say that 50 kilograms. We will say that something like 55.4 kilograms, or we can say something like 70 kilograms, okay? Something 70.5. Okay, so because these values are continuous because we are having something called decimal points. We are not sure about the values because you can in the range of you can get anything because we basically consider it as a scaling factors. Because if you go for a number line, let me take. I am having 0. See, here I am having 0, and here I am having 1. Okay, in my number line. Can you say the number of values in between this 0 and 1? How many numbers do I have in between 0 and 1? Real numbers. Anyone, it's a simple basic maths. I think it's a first standard, fourth, fifth class, fifth, sixth class maths.
Infinite, sir.
Yeah, it is infinite. You can have infinite number of values. Okay, you can have something called 0.5. You can have something called 0.000000001. Okay, you can have anything. We call this type of as a continuous values because they're not ending. See, for this value for 0.5, I can keep on repeating it. See, I can say for 0.5, I can write it as also 0.5, 0, 0, 0, 0, 0, 0, 0, 0, and goes on. Okay, like it is goes on. Like it is goes on. Okay, so it's a continuous value we are repeating. Okay, similarly, again we are having discrete values. So in case of our stock market, the label can be a continuous values. 19 rupees, 22.3 rupees, 40.2 rupees means 40 rupees 2 paisa, 22 rupees 3 paisa, 50 rupees, 10 rupees, 19 rupees. So we call this type of values as a continuous values. So the next is the discrete values. Discrete values. What are discrete? See, in case of this banking applications, what are the labels we are having? We are having only two labels. My output can be either 0 or 1. So do I am having any other decimal values in my in this label data? There is no decimal values. You can see. Okay. So let us go for again. Yeah. Plant leaf disease detection. Okay. Let us considering and considering. For plant leaf disease detection. In plant leaf disease detection, I am having certain leaves. Actually, there are certain diseases we call as leaf blight. I am encoded with 0. Leaf blight is encoded with 0. Then something called anthracnose. I am labeled as it is a 1. And something again called rust. It is labeled as 3. Similarly, rust, and again we have what are the plant disease rust. Uh, leaf blight, dark spots. 4. Sorry, I think it's a 2. It's 2. Sorry, 2. Go for 2. Go for 3. And go for healthy leaf. Okay. Healthy leaf will be 4. See, machine learning models, they will see instead of passing this 1 or 0, why can't we pass yes or no? See, this yes or no, they are in the string format. Can you perform any operation on this string, like any mathematical operation on this string? Upon any string, can you perform any any mathematical operation on a string. Not a concatenation, adding strings, subtracting something from one string
No,
to another
sir.
string. No, we cannot perform. Only you can perform any mathematical operations only on numbers only. When the data is in only numeric format, your machine learning models can learn something from it. Okay, so that's the reason. Of course, the data set. Of course, the data comes to in your hand. They are not always in a numerical format. Sometimes you might get something in text format. Sometimes you will get something in audio format. Sometimes you will get in an image format. Okay, there is a chances of lot of chances of getting another other type of data format other than numerical format. So there are certain process. So for to converting, when you are getting the text data, there is certain technique called NLP, natural language processing. So using this NLP, we can convert this text to a vectors. We will convert this text to a vectors, where the vectors will contain something numerical values in a reasonable way. Okay, like I'm not saying we are blindly giving some numbers to text or some numbers to some random numbers to a words, and we are giving them. Okay, it's not a blind technique. It is a very reasonable technique. NLP is a very reasonable technique. And for audio processing, we are having Librosa, we are having something feature extraction techniques where the audio files are converted to frequency domain and time domain. Okay, and time and frequency domain. Okay, at last, whatever your data format may be, either it may be text, either it may be images, either it may be audio. The main thing you must remember is that you have to convert the data into a numerical format. Okay, I will show you when we are dealing with images, how we when we are dealing with images and when we are dealing with text, how we will convert the text data to numerical data. I will show you, okay, in our coming classes. So okay, here I am giving the label 0, 1, 2, 3, 4. Okay, so I am what my model there is, I am having in a model. So let me take so this is my machine learning model. Okay, so this is my machine learning model. What I'm doing is that just I'm training a image. I'm giving something a leaf image, like I'm giving a leaf image to this machine learning model. Okay, so this machine learning model should predict whether these four diseases are present, whether these four diseases are present in my leaf, whether my leaf is affected with leaf blight. Okay, LF, LB, let us take BLB, or it is having any like anthracnose, or it is having a rust, or it is having a dark spot, or it is an healthy leaf. Okay, so I should build a model where if I'm training a image to a machine learning model, it should classify the image whether it is having any disease, like as I mentioned here, or whether it is an healthy leaf. Okay, so in this two process, see, in the process we are having something labeled data. Labeled data means our output value. Okay, your output value. Okay, your future data, your machine learning models in supervised learning. In supervised learning, your machine learning data, your machine learning models will try to find out the patterns in your uh, futures data using these labels. Using these labels, they will try to find out the patterns. Okay, basically, in my view, patterns are nothing but patterns are the weights we give to the models. Okay, while we are dealing with the machine learning models, I will tell you what are the weights. Okay, so the patterns. Okay, in supervised learning, what is the supervised learning is that there is something we are giving an output, like we are giving something or justification. You can justify in supervised learning. The machine learning models will justify will justify their training with other type of data. Means my machine learning models will justify they will justify their learning process. Justification is nothing but What happened? Okay. So if I'm saying some machine learning model that try to learn from this data, you are going in a wrong direction. Will my machine learning model will listen to me? It will not listen, because we should give something correct. We should give something that something data, so that machine learning model will try to recorrect it. It will try to learn from something. It will try to know that I have, whether my model is making any mistakes, or whether my model is making any wrong predictions. Okay, for that purpose we will give something called labels. Okay, so this label data will make this machine learning models to go in a good way, in a correct way. Okay, this is the supervised learning. Again, we are having unsupervised learning. Okay, actually there is a lot of time. So learn. So I will close this session soon. So in my unsupervised learning, I will have only my future column data. I will have only future column data. So this future column data, there is no label. Okay, in our supervised learning we are having label, but in our unsupervised learning there is no label involved here. Okay, so it has to try from, it has to learn from the data itself, and it has to try to correct from the data itself. There is no judging way. There is no other column that it can judge the performance of the models. Okay, that we call as a supervised learning. So again, supervised learning is classified into two segments. One is classification, the second is the regression. And in unsupervised we are having clustering and dimensionality reduction. Okay, so tomorrow we will start with the regression topic. So regression topic, and we will start with the linear regression. Okay, so are you people having any doubt regarding the session? Actually, I think this session is too boring, today's session, because there is nothing that I have shown you, because I was giving you some basic insights about the supervised and unsupervised learning. Okay, so are you people clear about it? Clear about the topic? Yeah, fine. Okay, fine, no problem. So I recommend each and every person that go for Kaggle website. Kaggle. Are you people familiar about this Kaggle? Kaggle. Anyone? Come on, give me a response, either yes or no. I'm not going to punish you whether you are going, whether you're saying a no for you. Okay?
No, sir, don't know, sir.
No, okay, fine. So only I'm getting a response from only one person. Where are the other persons? I think it's about something like, okay, people were left in the meeting.
They are in chat box, sir.
Yeah, okay, fine. So okay, the Kaggle is something I will show you. It will take hardly 5 minutes. So try this, type Kaggle. So you will get a web page. Okay, click on this Kaggle, your machine learning and data science community. So in that Kaggle, you can get a competitions. There are something competitions that are going on. Okay, you can get a different type of data sets. See the exercise that has given you, a SF salary exercise, I have taken it from this Kaggle only. Similarly, most of the data sets I will take from in this Kaggle only. Okay, so in Kaggle there is a competitions that is going on. Okay, if you want to go for the competition, let us go for this competition sections. Okay, this competition section, see, you will have, if you go down, you will have something like, there is a prize money also, 1 lakh. I think it's about 1 lakh dollars, and here also $1 lakh. Something, it is something beyond of your knowledge. We will try to go for it. Something COVID-19 detection, something like MLB player digital engagement forecasting, Hungry Chase, Google smartphone. Okay, so this is something beyond your knowledge. So let me go for this Titanic master. Something basics, you will get through the something basics called house prices, predicting the house prices in a cities, or predicting going for this Titanic data sets, digit recognizer. whether the digit typed by the users either is 0, 1, 2, 3 to 9. You have to classify, you have to detect the digit. Natural language process with the disaster management, crime detection using natural disaster. So you will come up with a number of competitions in this Kaggle. You can browse this Kaggle. You can go for these data sets. You will have different number of data sets. Go for any data sets. Go for this Wells Fargo. Okay, Wells Fargo is the American banking company. Wells Fargo stock data. Okay, we are having. Let's go for this. Okay, data set. In the Wells Fargo, if you go for download for if you want to download the data sets, you can see here download 804 KB. Download the data set. Okay, here you will give something statement. See statement. What is Wells Fargo? Okay, Wells Fargo and company. Something is a diversified community-based financial service company. Something it will give you. They will give you what is this data set and what you are going to do, what you are wanted to do. Okay, you can perform the whether they will say that build a model, machine learning model on this data set, or try to analyze this data set and give something best insights about these data sets. Okay, you can do everything. If you want to know the columns descriptions, you can go for here columns. You click on columns, we will have different type of columns. I think there were about something 7 columns. I think, yeah, there were about 7 columns. Details about the file. We are having something called open price, high price, low price, close value. I think it's about stock value. Okay, then price list, something we are having columns. So you can find the description values, and here in the description you will get something about what is this data set is about, and the second case what you are want to do, what you are intended to be do. Okay, so everything is mentioned in this websites. So you can download the data sets and you can perform your machine learning models. Okay, so this is the best overview. In our coming classes, the most of the task I will pick from this Kaggle only. Okay, so better to start browse through this website. Okay, I request everyone to go through this website and know, and you will know well about these data sets. There are much videos in YouTube also, so you can browse through them. Okay, yeah, okay, that's for today. Well, I want to leave. Well, like, of course, I've taken 10 minutes or more.
Okay, thank you, sir.
Fine, 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 fine. You can leave. You can leave. You can leave.